and then if new block is not getting created, then what will happen is you will not be able to run your application because block
Mhm.
creation has been stopped. So only thing we have to see here is how we ensure that our system is running 24/7. So to ensure that, what we do is we don't use single ordering node in the productions. Okay. So there will be multiple ordering nodes which will be running in the production. Okay. So if one node is getting down, then second node will be there who will just replace the stopped one, and then he will be doing the complete ordering process. So that is how it works internally.
Mhm.
Okay. And it
Yeah.
is based on deterministic consensus algorithm. So basically we just determine how the transaction will be going, or how the no block creation will be happening. Okay. So also one more thing here is the orders also maintain the list of organizations that are allowed to create the channels. Okay. So basically the channel creation and uh, so in different like, so in 2.2 version, the channel creation also was done by the ordering node only. Okay. And now also you have two options: you can bypass the ordering node, or you can use the ordering node to create a channel. Okay. So there is a order admin also available who is taking part in the creation of channel. Okay. So that kind of things will be done by ordering nodes. So whenever you will see the ordering nodes, ordering node is taking part in many activities. Okay. If you are trying to change anything in the configuration, of course you need a ordering node, because that is the auditing purpose, like auditing person. uh, if you don't include him, there is a security violation, because of course one organization should be there who will be acting as a auditor, or who will be acting as a auditor. So that one will be your ordering organization, or orders organizations.
Mhm.
Okay.
Yeah.
Now in the Hyperledger Fabric, we have three types of orders, like three types of consensus algorithm in the ordering services. So basically, um, we have Raft, Kafka, and Solo. Okay. So Solo is like a only single ordering service you are using. Only one order is there, and you are using that order. Okay. So Solo is deprecated when this new version came 2.x. Then Solo was deprecated,
Mhm.
and because it was not recommended for production also, because if you are using Solo, then what happens is, if Solo is down because of any reason, then your network is down. Okay. And the very first requirement of distributed network is it is not going to down anyway. Okay. So that is the very first property, or very first uh, characteristic of distributed networks. Then second one is Kafka. So Kafka is like a CFT implementation. Okay. So CFT meaning crash fault tolerance. Okay. And it is usually leader and followers node configuration. Okay. But Kafka also they have deprecated. Why? Because to implement the Kafka, it is a very complex process. Okay. So they try to make a Hyperledger Fabric as much as simple. Okay. The configuration should be very simple. The deployment should be very simple. But when we were using the Kafka, it was like a mess. Okay. So and some few other reasons also there. So they have deprecated that in 2.x, and now they only support one, that is Raft, because uh, architecture wise also it is very good, security wise also it is very good, and it is very easy to maintain, also easy to integrate with the Hyperledger Fabric. So right now only one consensus algorithm which we are using, that is Raft, and it is also based on CFT, and it also follows the leader and follower model. Okay. So leader and follower model will in the next session we are going to see that how the leader and follower model will be working. Okay, so three
Mhm.
types, but right now only one type is available, that is Raft consensus. And the thing is, in the Raft, what we can do is we can use single or order also, we can use multiple order also. So both the possibilities are possible. Okay. So single node also you can run, run multiple nodes and number of nodes in the Raft. Okay. Any questions here?
So this Raft will have to be installed separately if we once we configure the fabric.
No, it will come along with the Fabric.
Okay.
So only few configuration you will have to do
Mm-hmm.
to guide to direct the network configuration. Like this is the configuration algorithm you are going to use in our network. So the configuration, basic configuration will be there, and then it will be up and running along with the network.
Okay.
Okay. So now let's try to understand how the Raft is going to work. That is the main objective here. Okay. So we have to understand how internally Raft is working. Okay. Hyperledger Fabric is okay. That is fine. How that network will be working, that we'll see later. But right now, only Raft ordering system, inside the ordering system, how it works. So that demo I am going to show you.
Okay.
Okay. So here I have some. This is one the secrets of data. So on this website we have one demo available. So I will try to explain with this demo. Okay. So here we will understand the distributed consensus. Okay. So distributed consensus meaning when you have multiple nodes. Okay. So basically in the Raft we are going to have multiple ordering nodes basically, right? So if we have multiple ordering nodes, of course we have to have the agreement, or we have to have the consensus between, or we have to have the trust between this multiple ordering nodes also, right? Internally, correct? So how we achieve that? Let's see that. So first, let's understand what is a distributed consensus. Okay. So distributed consensus is, let's say, we have a single node system. Single node system is, let's say this is the one node as a database you can consider. Okay, only one database is there, and this is a database which is store a value. Okay, let's say it is storing a value x, right? Now there is a client. Okay, this green is a client. Now what happens is, this is a client and server setup. Green one is a client, blue one is my server. Server is basically on the server we have the database. Inside database one value is there, that is x. Okay. Now you want to update this x value. So what you are going to do is you will send a request from the client, right? So now they say client is sending a request. So if you are having a single database, just like right now we are having the applications like banking application or your social media applications, those are the applications which are based on this model, one client one server, right? So if you want to update anything directly, it will go to database and it will update the values. Okay, it is pretty simple, it's straightforward, right? Same thing is happening in every application.
Right.
Now consider, so here coming to an agreement, right, or the consensus, it is very easy with the one node, right? So if one node is there, it is very easy because you don't need to discuss with anything. Okay, whether the client which is sending some data, that data is correct or not, because if only one database is there, it is straightforward, it is very easy. But now let's consider you have three nodes now, okay, or multiple or n number of nodes. Then how you will decide, like the client who is sending the update request, it should go to which node, and if it is going to, let's say, first node, then how the second two nodes um, will be getting that, and how you will ensure that here we have the proper trust. Okay, because one can say, okay, I will not update. Second one say my value is not correct. Third one say, okay, the value which you are sending, that is not correct as per my database. Okay, so that is the problem of distributed consensus, because all are working in a distributed network. They are not connected to they are not in a sync. They can be in sync or they cannot be in sync. Okay, both cannot the both possibilities can be there. Okay. So this is the main problem of getting the trust in the distributed system. Okay, now to solve this problem we have the Raft. Okay, so now do you get the problem now?
Yeah.
What is the problem?
Yes.
Okay. So now let's see how Raft is solving this problem. Okay, so Raft is a protocol for implementing distributed consensus. Okay,
Mm-hmm.
in the distributed consensus, on the high level, let's say every node who is joining a network, okay, who is joining the ordering network or who is joining the Raft network, he that it will be in a three states. Okay, so three states are follower, candidate, and leader. Okay, so basically we are going to do a election process here. Okay, and in the general election also, like the election which is happening around you, in those elections also, basically you will find three types of person. Okay, one can be a follower. So as you know, the one who is voting, that is a follower.
Mm-hmm.
Some will be like candidate, like some candidates will be there, and they will be like, okay, please vote for us. Once they get the majority, once a candidate gets the majority, he will become a leader, right? Similar way, here also, whenever a new node joins, he will be joining as a follower. Okay, so total three states: follower, candidate, and leader. Whenever a first or whenever any node joins, he will be joining as a follower. He will be joining in a follower state. Okay, so follower state. Just look at the diagram. This is how the follower will look like. Okay, then so this is the follower state. Second one, the candidate state. Just look at the diagram.
Mm-hmm.
So dotted line on the edge.
Mm-hmm.
Then the final one is the leader. So complete circle. This is the leader state. So look at follower, candidate, and leader. Clear?
Mm-hmm.
So now what happens is, so all nodes are starting in the follower state. So everyone is follower now. Okay. There is a node name and there is a term, if you see in the diagram. Right? Correct?
Okay. Yes.
In our election also, uh, people with the election commission maintain the terms, right? Term is meaning the duration. Okay, so
Duration.
yeah,
Mm-hmm.
so let's say on first term this was the prime minister, second term another
Mm-hmm.
person was the prime minister, third term. So basically the number of election, okay, like how many times the election process election happened. Okay, so that we
Mm-hmm.
call it as a term. Okay, so here also the system will maintain the term. Okay, so let's say in the first term who was the leader,
Leader.
in second term who was the leader, right? Like this.
So
Now
can we call leader node as a endorsing node as well?
no, endorsement is not done by the order.
Okay.
Okay, endorsement is only done by the peers.
Endorsing peers. Okay.
Yes, endorsing peers.
Yeah, yeah, yeah. Okay, got
Okay,
it. Yes, yes.
block creation will be done by order.
Mm-hmm.
Okay, and block creation is different process, endorsement is a different process.
Mm-hmm.
Okay, but both are the part of the consensus only.
Okay.
Okay.
Mm-hmm.
So, yeah, so now here, and why we are using this Raft, why we are trying to understand this, because inside Raft also you are going to have multiple nodes, right? Your ordering service also will be having multiple nodes. So how you will achieve the consensus inside your Raft, that is what we are seeing right now.
Okay.
Okay, for a minute, forget about the transaction consensus. Okay,
Mm-hmm.
forget about
Mm-hmm.
the complete Hyperledger Fabric consensus. This is the internal consensus algorithm or internal consensus which is happening inside the Raft.
Mm-hmm.
Okay, and that is what we are trying to understand here.
Okay.
Okay, so now you see here every all the nodes are start on the follower state. Okay, then after some time, if they don't hear from they don't hear anything from the leader. Okay, so basically what happens is in our elections also, like leaders are the one who will be like okay, uh, addressing the people on timely basis, so that everyone will be knowing, okay, this is my leader and he is alive and he's in a position. Correct. Here also, every node, they will hear something, some they will get the random messages from the leader. Basically, a leader will be making sure, okay, I am alive. Okay, so don't try to become a candidate. Okay, but for a particular time, if a follower is not hearing anything from the candidate, from the leader, he will project himself as a candidate. Okay, so now if you see the node A, he become a candidate now. And so for once he become a candidate, then what he will be doing is he will ask for the votes. Okay, so first he will vote for himself, and then he will ask others, like, to provide the votes. So now this is the voting request he is sending. So the
Mm-hmm.
candidate then request vote from other nodes. Okay, if you forget, so here, this is how
Yeah.
he will be sending the voting request.
Mm-hmm.
Then other nodes, they will send the uh, they will revert back with their votes. So they will reply with their votes. Okay, so now he got the majority, because
Mm-hmm.
he got the majority. So total three votes he got: one vote from himself, and then two votes from other followers.
Mm-hmm.
So once he get the majority, he becomes the leader. So you can see the node A is the leader now. Okay,
Okay.
so this is the basic election process which is happening inside the Raft. Okay, so inside the Raft algorithm, this is how uh, this is how the election process will be working now. So complete process. You any questions here on the leader election? Now I will add
Mm, yeah.
new complexity here. Okay,
Mm-hmm.
or new conditions here. So basic election process is clear, right?
Yeah. Yeah. So far, it's clear.
Yep. Okay, now let's say, now if any client is sending any request, okay, so what will happen is all those requests will be coming to leader now. Okay, it will not go to any random node. Okay, so whatever request is coming from the client, now this will go through the leader. So this is how, so the request is coming from the client, and it will go to the leader now. Okay, it will not go to any other nodes. Now
Mm-hmm.
how the leader will be updating the values. Okay, leader is not having any direct permission, okay, to update directly into the database. Okay, so here also what will be happening is he will first send that request. Okay, let he will say, okay, one request came that is saying, okay, update the values by 5. Okay, so he will send that request to other followers also. Okay, he will ask, okay, verify your database, what is your current value, and what and this is the next value which is going to update. Okay, so now he will send the, yeah, first he will do a change in their entry log. So they maintain a logging system. Every node will be maintaining a logging system. So first they will add an entry in their node log, and after that he will send the, so right now you see set 5 is not committed yet. Okay, it is just an entry in their log. That's it. Now he will send the request. Okay, so this is the first replicate. So follower nodes, what they will be doing is they will check their ledger, and they will say, okay, this particular request is correct or not, which is saying no, set values to the 5, whether that is correct or not as per their own logging system or as per their own ledger. After that, they will revert back. Okay, once they will revert back, and so leader will wait until that, like if the majority of votes are coming, then after that he will he will say, okay, the request is fine, now we can update the value. So now you can see the entry is now committed, and the node state is 5 now. Okay, once it is committed, the leader again send the final value to the followers. Okay, and this time he will say, okay, update your ledger with this latest value. Okay, and at the last he will again send the response back to the client saying that the request has been updated successfully. Okay, so this is how we get the consensus in the Raft ordering system. So in the Hyperledger Fabric, if I say my transactions are coming, transaction request is coming from the system, and it is going to the Raft consensus algorithm. So inside Raft also those transactions are moving like this. Okay, so it is not like a direct straightforward my order will create the block. No, it will be it will go with this process, and then if they found that transaction request is fine, correct, then they will include that transaction inside the block, and they will create a block. Okay, yeah. So this process we call it as a log replication. Okay, so basically if you see that replication is happening, right, for the logs. First,
what if any of node denies the update? So for example, node C, for example.
So see, generally what happens is there is a actually no denying process, but if they found, okay, this request is not fine with their ledger, so they will not revert back anything. Okay, if that request is not fulfilled by their ledger. Okay,
so in that case, will it still update all the nodes data?
Yes, so because leader is only interested in the majority. Okay, if he gets the majority, then he will update the values, because if one node is not is out of sync, okay, if he is not having the update value, the leader job is to update their ledger also forcefully. Okay, because if you are out of sync, then of course you should not be in a network. If you are in the network, you should not be out of sync. Okay, because it is a private network, right? It is not public network where we have to see the, okay, we have to have all the nodes and then that mining process and all nodes. We are not having that. This is a private network. We have only decided, okay, this node will be my ordering node, this many ordering node will be there. Okay, we have the identity of those ordering nodes because we have only decided, right? So that is how it works internally. Okay, and so this is LoRa application. Now one another complex thing, let's say at the one time, okay, two ordering nodes become the candidate. Okay, and how a re-election will be there, or how, let's say, more than two become the candidate at the same time. So how those kind of things will be working. So now we'll see those kind of complexity here. Okay, or those kind of scenarios. So now if you see in the diagram, do you see any white line inside?
Yes.
One white line is running, right?
Yes.
On the border.
On the border.
So that is the timeout. Okay. So there will be two timeout settings. this is very first timeout, okay, which is with the white border which you see. So whenever a node joins, so he joins as a follower. So once he joins, then that follower will be having a timeout time, that is a random time. It can be in the range of 300 nanoseconds, okay, or milliseconds. So random, any time will be assigned to a particular node, and then he will be running that timeout, okay, until unless he gets any or he hear anything from the leader, okay, or any other node, okay. So now let's see. So first is the, so this white timeout which is happening, that is the election timeout, okay. This is the election timeout. Now in the election timeout, all timeouts is going on, right? And the very first timeout which gets completed, okay, so that person will become a candidate, okay. So now if you see, so it is random between 150 ms to 300 ms. So now it is going on. So the very first, so A completed the timeout very first. Once he completed the timeout, he will become a candidate. He will first vote for himself, so vote count is 1, and the term leader election term is first, okay. Now he will send the voting request to other. Once others get the voting request, meaning others get the a message from any other node in the system, okay. Once other gets the voting request or any other messages, then their timeout will be reset, okay. So now if you see, the timeout got reset for both B and C, right?
Okay.
Now they will again revert back with the response. So now my candidate got the majority and he become a leader. Now the timeout of B and C, it is running continuously, right? They're not going to stop the timeout. That is a continuous process. But what is the leader job here is? Leader job is here is to make sure that he is alive, and he should send the heartbeats saying that I am alive. So these are the, so red one which you see, that is the heartbeat timeout, okay. So he will be sending this again and again, okay, and this is a continuous process which will be happening again and again to just reset the timeout of every nodes, okay. So making sure that my leader is alive and he is sending the heartbeat. Clear?
Okay.
So this is how everyone will get to know, okay, our leader is there. So our leader is there, then we cannot become a candidate, okay. And how they cannot become the candidate, because the heartbeat is running continuously, right? So heartbeat is running and it is getting reset again and again. If heartbeat is completed, then only he can become the candidate, right? Now,
so if heartbeat timeout is not written by the leader, then that timeout process will be applicable for other nodes, right?
yeah.
So
So
if timeout,
let's say node A is stopped sending the heartbeat, okay. So then what will happen is A or B, anyone gets will complete the timeout very fast. So I think in this situation C will complete the timeout, right?
Right.
And then anyone who is getting who will complete the timeout, then he will become a candidate. So that example is here. So let's stop the node A or leader. So let's stop the leader and watch the re-election, how the re-election is going to happen. So node A is down and timeout is getting so it is running. So now my B is getting to is completed the timeout first, and now on the term 2, B become the leader. Okay. Now if node A again joins the system, okay, so he is not leader anymore, right? He will join as a follower again. Okay, so this is term 2 and leader is B. Now let's say we have 4 nodes now. Okay, so just look at the diagram. So now 2 nodes are have completed the timeout at the same time, right? All have joined as a follower, and 2 has completed the timeout at the same time. Okay, and uh, both are sending the voting request. Okay, so let's check it out how it happens. So now vote count, you can see right now both are at 1 1. Now both are at 2 2, and both are 2 2, right? So there is a tie, right? Then internal timeout that is running, right? Let me okay, it is not going to 1 minute. Okay, 1 minute, huh? Let me just rerun this because it is getting. Okay, so yeah, so here 2 will become the so there will be a tie. Just look at the diagram. So A and B, right? There is a tie. Both will be getting the vote count, same vote count, 2 and 2. Okay, but internally, if you see, one another timeout is happening. Like that is a election timeout. That is a running process. Okay, like a person who has become the candidate also, but internally one timeout is going on. That is a election timeout. Okay, that is the running process. So that will be again and again it will be running. And second time, if anyone completes that, okay, so now both are at 2, but internal timeout is going on, and A is going to complete first. Okay, see, D completed very first, right? So once D completed very first, then he become a candidate in the leader. So this is how it works in the Raft when you have the multiple ordering nodes. Clear?
Okay. Okay.
So this is the log. This is the complete one, and another one is log replication. So that is an example which you can just check it out later on also. But the main process is how the leader election is working and how the timeout is happening. Okay, so this is how the Raft works internally, and this example we can check it out when we run the network, right? So in the logs we can have like we can just check it out. Okay, this is how the election process is working. Like in a term 2, this is the uh, um, node A is the leader, and term 3 node C is the leader, so that we can check it out in the Hyperledger Fabric logs. Okay, so when we will run the network, I will show you how you can check it out, who is the leader, who is the followers right now in this term and all. Okay. Yeah, any question?
No, I don't think any questions as such. Guys, do you have any?
No, sir.
Okay, fine. So her next topic which we are having is the channel. Okay, so let's understand what is the channel. And okay, one minute, just to give me one. Okay, so now let's understand what is the channel in the Hyperledger Fabric. Okay, so just now we have seen orders and peers, right? So basically when we create the organizations, so if you just look at the high level, first we are going to have the organizations in our network. Inside organizations we have the peers. So basically two types of organization you will see, order organization and peer organizations, correct? In the order organization you will find, okay, you will have ordering nodes which will be working on the Raft consensus algorithm. In the peer organization you will have, okay, org1 is there, so inside org1 you will have some peers, peer 1, peer 2, peer 3, and so on. And org2 also you will have some peers, correct?
Right.
Now how the transaction will be flowing? Okay, there should be some way, right? There should be some layer on which you can do the transactions. So now between the organizations, if you want to do the transactions, then we have to create a layer, or we have to create a communication medium. That communication medium we call it as a channel. Okay, remember one thing, channel will provide the separate communication between the organizations. Okay, remember this term. If you want to create a communication medium between the organizations, then you will have to create the channel. Okay, so let's say if you want to do establish the communication, or if you want to do some transactions between three organizations, org1, org2, org3. Okay, so you can create a channel. That channel you can create, like let's say channel 1, but in your network you have total 5 organizations. Okay, you have org4 and org5 also. Okay, but in the channel 1 you have only included 3 channels, sorry, 3 organizations, org1, org2, and org3. Okay, so for channel 1 only 3 organizations can share the data, can do the transactions, and only those 3 organizations will able to see the data of that particular channel. 4 and 5 cannot see any kind of data which is happening on the channel 1. Now let's say a second channel, if you want to create, that channel is channel 2. Okay, in this channel you included org4 and org5. Okay, so org1, org2 and org3 cannot see data of channel 2. Only org4 and 5 can see the data, can update the data. Correct?
Yeah.
So we are doing a separation, right? Three organizations can share the data on one channel. Other two organizations can share the data of on the second channel. Now there is a third condition. Okay, in the third condition, let's say you are creating a third channel, that is channel 3. Okay, in channel 3 you want to include organization 1, 4 and 5. Okay, so what will happen is whatever data is flowing on channel 3, that data can be seen by channel 1, channel 2, channel 4 and org 1, org 4 and org 5. Okay, but here one thing to keep in mind is the data will be stored on channel wise. Okay, so organization 1 is there, he can see two channels data, channel 3 and channel 1. Okay, why? Because he is part of two channels. So one thing to remember is one peer can be part of multiple channels. Okay, one organization can be part of multiple channels. Okay, whenever we create a new channel, one complete new blockchain will be created. Okay, or one new chain will be created. Okay, so in the Bitcoin, I think if you see these main chain and sub chains, right? You know that concept. If not, then visualize in this way. Right now, if I'm creating a channel, meaning I am creating a new chain. Okay, so let's say my first block is Genesis block, then I have created a channel. Then on that channel, I am doing some transactions. So let's say some 100 transactions I did, and those transactions are stored in the blocks. And let's say some 10 blocks has been created. Block 1 will block 2, block 3. So these blocks, this chain is for my channel 1. Now after some time, we have created the second channel. So second channel also will be start from block number 1 after the Genesis block. Okay, but that will be a separate chain only, complete separate chain. It will not any related to channel 1 chain. It will be completely different. Just like if you see here in this diagram, we have two channels, vehicle channel and insurance channel. Okay, and three organizations we are having, org 1, org 2 and org 3. Org 1 is part of both the channels. Okay, so org 1 can see vehicle channel data also and insurance channel data also. Okay, org 2 can only see data of vehicle channel. It cannot see any data on insurance channel. Similarly, org 3 cannot see any data on vehicle channel. It can only see the data on insurance channel. Okay, so we are separating the data, or we are managing a privacy here on the organization level. Okay, now in org 1 you have 5 peers, so all 5 peers can see vehicle channel data and insurance channel data. If you have 10 peers in the org 2, all 10 peers can see the vehicle channel data. Okay, so it is on organization level. Okay, so whenever you are going to create a channel, channels will be created on the organization's level. Okay, so remember this
and whatever permissions that are there for that org, all the peers can see that data.
Correct. So by default, all the permission will go to the peers.
Peers.
Okay.
Yeah.
So this is the concept of the channels in the Fabric. Okay. So I hope this is clear. And when we are going to create a channel in practical also, that time also it will be very clear to you.
Yeah.
So next we have the identity. So yeah, this we'll see in the later session. Okay, tomorrow. Identity is the big one. I have to explain many things. So we'll continue with the identity tomorrow.
Yeah, that's it.
Yeah. Any questions? Anything?
No questions as
Yeah,
such.
yeah.
Theoretically, I think it is making sense, but once we start practically doing it, we may have some questions for sure.
Yeah. Okay. Yes,
Hello.
someone was. Yes, yes.
Yes.
Uh, if a peer is offline, if suppose a peer is in the channel and he is offline
Mhm.
for some time, and after coming online, he is already in the channel or he's out of the channel.
He will be in a channel, okay, but he will be out of sync with the ledger. So the very first thing what will happen is the leader peer
Mhm.
job is to sync his ledger.
Right.
Okay.
Okay.
Yeah.
So leader peer will make sure that his ledger is up to date. So let's say current block was block number 10 and your peer was down for 1 hour. And after 1 hour, he came, the current block number is 40. Okay, so he's out of 30 blocks, right? So
Yeah.
the leader peer job is the very first second he join, then he starts again. Then he will be forcefully he will be synced with the those 30 blocks, so that he will be up to date with the all the blocks.
Yeah.
That process I have those practicals will do in the labs. Okay, we'll down one peer, then we'll check it out. Okay, if I again up this peer, then what is going to happen? Okay,
Yeah.
fine. So that's it.
Okay.
Yep.
Thanks.
Thank
Yeah.
you.
Thanks,
Thanks
Dan.
everyone.
Thanks. Have a good day. Bye.
Bye.